My name is Brent Teirney. I work for Suppression Operations. I've been working at the company now for over 15 years. I look after all the fire suppression systems. I'm at Creyke Beck Power today. I've been testing on the actual fire suppression system and also carrying out a room integrity. What excites me about the job is the actual fault finding. Each day is totally different. I always find different ways to fix things. Always learning every single day. That's why it's a good job to have.
What I've done there now is make a nice tight seal on the door frame so there's no gaps. What I've done there, put some supports in what make it all nice and tight. What I'll do now, I'll take measurements of the actual room itself, do the volume and then work out how much gas is going in the actual container. What I do then, I make sure it's correct to the initial concentration, to the design concentration, and then I carry out the test and it will give me some readings.
So what I'm going to do now, I'm going to demonstrate as though there actually is a fire in the actual container. When the container goes off into fire, all the dampers close, all the HVAC shuts down, which simulates the actual fire state. Now we're in a fire state situation, what we can do, we can actually do the room integrity test now. We know all the dampers are all closed, so all we have to do now is do the test. What an actual integrity test is where I actually put a fan inside the actual container. What that does then, it pressurizes the room and depressurizes the room, and that gives me a hold time. It needs to be a hold time of 10 minutes for British standards. Anything above the 10 minutes is a pass, anything below it'll need resealing. Well, this is the actual gauge, what actually controls the fan. What I have to do, I have to select a range, which will determine the fan speed. With the fan speed, I have to take up to 60 pascals to get the actual correct pressure of the actual room. And what it does then, it takes an average reading and take it all the way down to 10 pascals. Now taking the average reading, it's going to start plotting it on my program. Now go down to 49 pascals. Now going down to 27 pascals. What you'll hear you'll hear the fan start to slow down a bit. What that does then, I'll have to change the range of the fan. So what I do, I take the actual smaller gauge out for the time being. Turn the fan around now so it is now pressurising the actual room. So this time now I'm just going to change it back to the range which is in now. So this time now we're going to pressurise the room so that the fan is now blowing inside the room. I'm going to change it to a smaller one again. Just makes the fan work a lot harder on the last test. This is the last part of the test now. This will take it down to the last reading. I've completed the actual test. What it's done is put figures in. Every time it's got to a certain pascal, it's done a reading of how much pressure is in the actual room. What this does then, it gives me a predicted hold time, because basically with the fire suppression systems it has to have a 10-minute hold time minimum. So what this one is saying that it's passed at 11.6 minutes, so the gas would stay in this area for 11.6 minutes. My opinion on the clothing is nice and comfy, nice and warm, especially on a cold day like this. Nice and able to move in the actual pants, and I can bend down nice and easily when I'm doing my room integrity kit. And yeah, I'm impressed.